In this video, I will be solving this graph here. So first we have to understand that this graph is saying, this graph shows the volume of gasoline left in the car's tank, V liters, as a function of the distance traveled, D, in hundreds of kilometers. Determine the domain and range of the graph. So right off the bat, it's asking us what the domain and range of the graph is. So I have to understand that what helps me is picturing a table, splitting it down the middle, putting X and Y. Your domain will always be the X and your range will always be the Y. And in this instance, you see that the X or horizontal axis is labeled as D. So the D would be the domain, and that the Y-axis or vertical axis is labeled as V. So the domain and range of the graph, the domain of the graph would be distance, and the range of the graph would be fuel left in the tank. Now, question A is asking us, determine the horizontal and vertical intercepts. Describe what the point of intersections represent. Now, the points of intersection, sorry, I cannot speak. Just asking at what point, because these are the axes, right? This is the horizontal axis. This is the vertical axis. So at what point does this line cross or intercept the axes? So here we're going to start with the D-axis or horizontal axis, and we're going to come here, and we always start with the X. So we're going to come along, and it intercepts at 5. So but we cannot say that the horizontal intercept is 5. We have to write it as a coordinate. So we go here, we show X intercept, because that's basically what it is. We could put D there, equals bracket 5, because we always start with our X value, 0, because there is no Y. It's not going up by anything. It's only intercepting at the X-axis, or horizontal axis. In this case would be D-axis. So we should always remember that this is how coordinates go. X, Y. So now we come here. We go, what is the Y? So we just go here, and we understand that 0, X equals 0. Oh, Y, I. 0, because there's nothing on the X. Go up, 60. That is our horizontal and vertical intercepts. And what do these points of intersection represent? So the X-intercepts represents in the saying that at a distance of 500 kilometers, there was no fuel left in the tank. The vertical intercept is saying that at 0 kilometers, there was 60 liters of fuel left in the tank. B is asking us, determine the rate of change. What does it represent? So the rate of change, I like to think of it as just the slope. It's just the slope, really. So this line here and how it's going down, that's the rate of change. So I'm just going to start this intersection here, and we're going to see just when does it, just hit right across. I don't know how to describe this. So the rate of change is, I'm going to do this. I did not do this beforehand. Boom, down 1, so -1 over 1. Because you have to remember, it's always rise over run. Obviously, when you think of rise, you think of it going up. So that's why when it's going down, we think of -1. So the rate of change is -1 liters per kilometer. Give or take, because it's not necessarily. So -1 liter per 1 kilometer. Or I guess I could try and figure that out. So let's see. This goes up by 12. This goes up by 12. So it's more like, that's I was wrong. The rate of change equals -12 liters for every half a kilometer. See, because it's going down 12, it is going down 6. It is going down 6. That's my bad. It is going down 6 liters for every half a kilometer. Or every 50 kilometers would be way better. Again, my brain is not working. I apologize to both Jameson and myself because I know I'll be watching this video over to understand how this stuff works. So now that I finally have an operational brain, the rate of change is -6 liters. So for every 50 kilometers traveled, we lose 6 liters. Rise over run. What does it represent? It's basically saying that for every 50 kilometers traveled, we lose 6 liters of fuel. Pretty simple. C, determine the independent and dependent, oh my goodness, you know what I mean. C as asking, determine the independent and dependent variables. So we're going to start. The independent is always on the horizontal axis. So distance is the independent. And dependent equals fuel left. Now, why is that? And I could give a more reasonable explanation as to why this is distance, which would be because however much fuel you have left is dependent on how far you have traveled. How far you've traveled is not dependent on what fuel you have left. It's the other way around. So that is why that's the independent and that's the dependent, because this depends on this. D, determine the domain and range of the graph in set notation. So as we understand, this set notation is essentially, memory is correct. So we already figured out the domain and range, right? So now we want to know how far left does the x value or d value go? How far right does it go? So obviously we come over here. This 0 is as far as it goes. And right here, 5, that's as far as it goes, right? So we're going to start here. That weird squiggly line. X, that weird line. So then we're going to start here. 0 is greater than or equal to. X is less than or equal to 5. Close bracket. Why is this? Because 0 is the smallest number we have and 5 is the largest. So obviously x is greater than or equal to 0, but it's less than or equal to 5 because that's just how big. It cannot be smaller than 0 and it cannot be smaller than 5 because that's where it ends. Now we're going to do the same for y. So this axis here, how far up does it go and how far down does it go? And it's very same concept, 0. We're going to start here with this weird graph. Y, ooh, and I need to fix myself. Because that is not x and that is not y. It's d. D, haha. You thought you had me on something, Jameson. So v, and why is it d? Because obviously it's not labeled as x, it's labeled as d and v. So v is 0 is less than or equal to v, which is less than or equal to 60. Because it cannot be lower than 0 and it cannot be higher than 60 because that is where the graph ends. Right there. That was terrible. I think I just messed up. So yeah, that is set notation. How much fuel is left in the tank after traveling 200 kilometers? Now we have to understand that this says distance hundreds of kilometers. So when it says 7, it's talking about 700 kilometers. So we come over here and we try and find what's 200 kilometers? Well, right there. It's just 2. So we go up till we hit the graph. Okay, we don't need to care about that coordinate. We just need to go over. So when it's asking how much fuel is left in the tank after traveling 200 kilometers, well, 36 liters. So this would be 36 liters. What distance has been traveled if you have 30 liters left in the tank? Now we have to have a rough estimate. So we know that 24 take away 12 is 12. So up right here, that is obviously 6 because 6 is half of 12. So we go to 36, which would be our greatest reference point, go back, and that's 30 right there. So what we want to do is we want to go here at 30 and then down. And obviously it's skipping, so this would be 2.5, which would be roughly 250 kilometers. 250 kilometers. Because 2.5 times 100 is 250. And that is how you solve this graph. Thanks for watching.